factorial. 6 factorial is the same as what? 6, 5 times 4 times 3 times 2 times 1. Blast off, right? Which is 720. We talked about that. Okay, we're not doing all of these. We're just going to do a few. 5 factorial over 3 factorial. Now, if you look at it, 5 factorial is 5 times 4 times 3 times 2 times 1 blast off over 3 times 2 times 1 blast off, right? So we are going to look at that. Is there any way that we can have anything that could possibly cancel off in those two? 3, 2, 1, which is just the same as what? Yeah. So we can either cancel these right off and say that this is 20, or another way we could write it is we could write it as 5 times 4 times 3 factorial, technically, right? 3, 2, 1 is 3 factorial. And the reason why we stopped there is because it matches the bottom. And then those cancel and we're left with 20. True? All right. Then we're going to flip to the brand new booklet. We're going to bypass the other stuff on the bottom for now. So we're here. So this is the permutation formula, nPr. Number of permutations from a set of n different objects where r of them are used in each arrangement. The catch here with nPr is that n has to be bigger than r. We've talked about this. You can't have like 3 hats and then arrange 7 of them, right? That doesn't make sense. So your first number, this n, has to be at least the same or greater than r. So for example, if I had 7 different textbooks, and I wanted to arrange means order matters, correct? If I'm arranging anything, I'm giving it an order. I'm arranging it in a specific pattern. If I took flowers and I threw them in a vase, did I arrange them? Or did I just toss them in there? But if I'm actually putting them in a specific order, I'm arranging them, right? Then order matters is a permutation. Okay? So I'm going to arrange 5 textbooks, 5 of them. So how we would have done this to this point is I would go 1, 2, 3, 4, 5. The moment I'm doing the blanks, I'm giving it order, right? I'm putting something in the first blank. It's going to be on its far left. Then the next, then the far right. Correct? I'm giving them specific spots. So how many would go in this first blank? 7. Then 6. Why am I going down by 1 each time? You're boxing and holding. You have to leave a textbook behind, right? You went 7, 7, 7, 7, 7. You're never actually leaving a textbook behind, and you're never actually ever arranging them. Now, this is the catch. If you box and hold, or if you're leaving them go down by 1, which means you're keeping one and leaving it behind, you can also use the permutation formula. So if this was 7, 7, 7, 7, 7, I can't use the nPr formula. But if it's 7, and I go down by 1 each time, I can use the nPr formula. So I can go 7, P, and why I use P is because it's a permutation, the order matters. And how many did I choose to arrange? 5, so I put a 5 here. So do you see how if I arrange them all, I'd go 7P7? But I can't go 5P7. And people will, on the diploma, have tried to call me into the room, and I can't come into your room because I'm not allowed to go into any rooms. You gotta have a diploma in them for math because I'm a math teacher. So if you teach a subject, you're not allowed to be in there. They try and call me in, they're like, my calculator doesn't work. It's not your calculator, it's you. Sometimes it's your calculator, but where this goes wrong is not because people can't type it in, it's because they're typing in, what do you think? 7P5. 7P5 would be good. What are they typing in? 5P7. 5P7. They're saying I have 5 objects, I'm arranging 7. And if I say, if it was in person, and I said, oh, you have 5 objects and you're arranging 7, they'd be like, that's stupid. I'd be like, yeah. So is writing 5P7. Okay, do you know what I mean? Has to be the amount you're choosing from. Has to be the same amount or greater than the amount you're choosing. Right? So 7P5, it's in the same place as math. Let's try it again. So we've done this before. Let's try again. 7. Everyone pick up your calculators. 7. Math. Go to where factorial is, right? The PRB, and you're going to pick which one? nPr, which is number 2?
Yeah.
NCR is 3, I think. So it's number 2, and then you're going to put 5, and then you're going to hit enter, right? And you should get the same answer. They are the same. We agree? Not for combination. For permutation. Yes. Yeah. Yeah. Does that make sense? So it's the same thing. So it's only if you go down by 1 each time. If you went 7, 6, 4, 3, 1, you can't use it. Right? It's going down by 1 each time. Okay. So here it says, remember above when you were ordering 3 stuffies? So on that previous page, we ordered 3 stuffies. And you had 6 different arrangements. You had 3 stuffies and you ordered them into 3 spaces. So we went like this. We had 3 stuffies for this one, but then we left the stuffy behind. Then we had 2. Then we had 1, correct? And I said we could write that as 3 factorial. What else we write it as? 3 P. So we start off with the number 3, so that goes 3, right? And then how many blanks do we have? 3. So this is how many. This is the total amount. And this is how many we choose. Or the number of blanks in FCP. FCP, what? Number of blanks in FCP. All right. So, 8P3. I want you to put that into your calculator. 8P3, go. P3. Make sure you're typing. 8P3. What do we get? Yeah. How could I represent this with fundamental counting principle with the blanks? How many blanks would I have? 3. This is the number of blanks, correct? And what do I start with? 8, and then I have to go down by 1 each time, right? So I can't go 8, 8, 8. I would have 8, then 7, then 6. Does anyone have any scenario this could be? 8P3, put your hand up if you have a scenario. Any idea? What's an object in the world? Pants? Cool. We have 8 pairs of pants. And I'm going to choose how many of them? 3. If I just do 8 and I choose 3, that's actually a combination. Because I didn't give them any order, right? I'm just taking 8 and choosing 3, throwing it in my backpack and moving on. What would I have to do in order for that to be a P? Pick 3 pants to wear what? Make sure you're not on your phones. On 3 different days. Something for Monday, something for Tuesday, something for Wednesday. We agree? Then would I give it an order? Yes. Then it would be P. Then it would be subjective. Then I could use it for here. Okay. I want you to do B. I want you to put B in your calculator, and then I want you to represent it in fundamental counting. So, 1, 2, 3, 4, 5 blanks. This is the number of blanks. This is the number I start with. 6, 5, 4, 3, 2, which is actually the same as 6 factorial. And some people may fight me on that because they're like, it didn't go to 1 and blast off. But when I multiply by 1, does it do anything? No. So technically, you could get away with putting 6 factorial. Now, this is actually not 6 factorial, but the answer is 7. All right. Example 4. Isla has downloaded 10 new songs from, and it looks like Lila because font sucks, and that's my daughter's name, and I didn't realize it was going to have an L-I, but it's Isla. So she was baptized Lila. People call her Ilya. They swap it. So she's like, okay. So, Isla has downloaded 10 new songs from an online music store. She wants to create a playlist. You can still do playlists in Spotify, dude. You're going to be okay, I promise. So, all right. She wants to create a playlist using 6 of these songs. Now, here it says arranged. Arranged means it's a permutation, correct? Arranged means I can use those blanks. Yes? I don't have to, but I can. Okay, and a lot of people like visualizing it in blanks. I do too. Ooh. Okay. How many different 6-song playlists? So how many are we choosing? 6. So we could go 10p6. Now the reason why I can do 10p6 is I want 6 different songs on my playlist, correct? But if I allowed it to be all 6 of the same songs, which would be a really crappy playlist, I wouldn't be able to go 10p6, would I? I would have to go 10, 10, 10, 10, 10, 10, and multiply them, correct? So if I'm allowed to repeat the object and not box and hold it, I can't use the p. Does that make sense? So for this one, the way I could represent it is I have 6 blanks, 10, 9, 8, 7, 6, 5. What's the answer? Pardon?
I got 151,000.
Thank you. So a lot of people think, oh, that's not a lot of playlists, and then they get the answer like, oh, that is a lot of playlists, right? So here it says 9 girls are available to fill 3 positions on a hockey team, center, winger, and defense. Did I give them different jobs? Center, winger, defense. Those are different jobs, correct? So if I give them different jobs, it is a permutation, correct? Because order matters. Because you're not going to go put a forward in defense. You're not going to go put a defense in forward when they're 18. It ain't going to be pretty, okay? So they'll do it, but they won't be as good as the rest, as they would be if they were in their actual position, okay? So because I gave them positions, different positions, I should say, sorry, it's a permutation. Okay? Does that make sense? If I just picked 3 people to throw on a hockey team, which I don't think you'd ever do, because what could you get? Maybe 3 defense. But if I just threw them onto a hockey team, or I took 3 people from a hockey team and I sent them on a trip to the same place, it would be a C, because order wouldn't matter. Okay? All right. If all 3 girls are equally competent in each position, which is not even possible, but good, cool. Very well rounded. They're in grade 1. How many different ways can the position be filled? So I can say I have 9 girls P3, or 3 blanks and go 9 times 8 times 7. What's my answer? Pardon? 500. Now, I can't believe no one has disciplined me harshly. What am I not doing? Starts with an S. Oh, I didn't even have to keep the rhymes with. I didn't do any sentences. This is terrible. So, there are, even if you use the wrong there, I might judge you a little. Maybe not. I don't even care. I'll give you the full mark. I'll probably bypass that completely. There are 6 songs. So when you think I am hardcore, I'm not. Only about certain things. It does drive me a little crazy when you are using a word from the word above and you don't spell it the same. That's a little crazy, but I will still mark it right. There are 6 songs. There are 6 song playlists. There are, oh my Lanta. There are 151,200 different, ooh, my goodness. I'll even give you the mark for this. Put an arrow in. 6 song playlists. You should be writing this down because I promise you, you did not write a sentence and now you're still not writing a sentence and making me sad. Very, very sad, like tears dropping down my face. Brady, sentence.
I already did that.
I don't believe you. Full sentence exactly the same?
Yeah, but I just decided to write it like how Yoda would speak because I am bored.
They're not going to mark it properly with Yoda, but that's okay.
I just wrote it 504 different ways. I was writing
You still have to say the positions can be filled. You got to write the sentence more.
Yeah.
Okay, so how many different ways can the positions be filled? 504 different ways isn't enough. And even if this is a terrible sentence, we'll still accept it. 504 different ways the positions can be filled. Is this a great sentence? It's sufficient. Oh, sorry. X-ray vision. I can't see anything when I close my eyes. You can't see anything when I stand on the board. Same. All right. You guys try this, example 6 and example 7, please. So we have at a used car lot, 7 different models. Shh. This matters. Because if they're not different models of cars, you can't tell them apart. So if I parked 3 together and they were all the same black, same model, same everything, and I moved them around and then told you to open your eyes up, you'd be like, they're the exact same, right? But if they're different models, but they're the same black, you can tell them apart. Like if one's a Ford Focus and one is like a Ford F-150, and then one is like Ford Mustang, yeah. We can tell those apart, okay? Even if they're the exact same black, okay? So here it says, at a used car lot, 7 different car models are to be parked close to the street for easy viewing. The 3 red cars must be parked so that there's a red car on each end, and the 3rd red car has to be exactly in the middle. Does it say anything about the black ones? It just can't be in the spots of the red, right? So 1, 2, 3, 4, 5, 6, 7. I can have red here, which is 3 options, and then I have to leave one behind or I'm never parking the cars, correct? Then 2, then 1, then how many cars do I have left? 4, 3, 2, 1. And then you have to make sure you have multiplication dots. So you could do it this way, or let me have you visualize something. This is 4, and you can actually visualize it, unlike me, who cannot visualize things. 2, 1, and then this would be 3, 2, 1. Do you see that? Do you see how the red makes 4, 3, 2, 1 blast off, and the green or the blue makes 3, 2, 1 blast off? So technically, I could write this as 4 factorial, 3 factorial. And we need to know that because that's the way they could write the multiple choice answer, correct? What is the actual answer? Now the other thing you could do is 4 factorial is actually 4p4, and 3 factorial is actually 3p3, so they could represent it that way as well.
Why 2 and 3, 1, 2? Why is that order? It's like could it not be like 1, 3, 2 or 2, 3, 2 or whatever? Like for the
Just because 3 factorial is you start at a number and go down by 1 each time to 1. So if I went 3, 2, 1, that's 3 factorial.
Yeah, but why did you skip the middle one? Why did you go over to the right and do?
Because I just wanted it in 3, 2, 1. If I went 3, 1, 2, that doesn't scream 3 factorial as much.
You did 3, 1, 2, 1, 4.
Yeah, but I didn't when I wrote it. I went 3, 2, 1.
Yeah, but can you switch the 2 and the 1?
Yeah. Could you have started, went to the middle, and then to the end? Absolutely. Yep. Because we just had to have them in specific spots. Yep. I just like doing the end and the middle. If you went 3, 2, 1, you were totally fine. Yep. I get what you're saying. The 3 cars must be parked side by side. 1, 2, 3 red cars. Gosh, that's right. 1, 2, 3, 4, 5, 6, 7. How many ways can the 7 cars be parked? So I have to have 7 blanks. The 3 red cars have to be side by side, so I'm going to hook them together. I have 3, then 2, then 1, then 4, 3, 2, 1. Currently, they're together at the front. What do I have to multiply to keep them together? 5. It's always one more than the hook together, correct? Because if you think about it, this is the 3 cars hooked together, and here's the other 4. This is one way, 2, 3, 4, 5, correct? So it's always one more than the hooked together numbers, because you can have one at the front, one at the back, and then in between. So that's 1, 2, 3, 4, 5 different cases where I could move those 3 cars. See what I'm saying? Here's the 4. 1, 2, 3, 4, 5 different cases where I can move them, but they'd still be together. So I have to multiply it by 5. Now the only reason why I show multiplication by 5 is to prove that that's 5 cases. You could have went dot 5. You're totally right. It's the same thing, right? Multiplication dot or the multiplication sign mean the same thing. I just use the multiplication to show it to you. So this is 720. Here we have a social insurance number, SIN in Canada, costs consists of a 9-digit number that uses the digits 0 to 9. There are no restrictions, I'm struggling, on the digits selected for each position in the number. How many sins can be created if each digit can be repeated? And we need a 9-digit number. And we're using 0 to 9. How does this compare with the number of sins that can be created if no repetition is allowed and it must start with a 6? So we're comparing them, which means we're going to have to like actually subtract them to see what the difference is, right? So we have our 2, 3, 4, 5, 6, 7, 8, 9, our big one without any restrictions, which means this would be 0 to 9. So that's 9, obviously, right? What is 0 to 9? 10. Use your fingers if you have to, remember? You look silly if you don't use the right number. Okay, so 10 times 10 times 10 times 10 times 10, which is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. When you multiply tens, it's just the number of zeros, yeah? You could technically put in as 10 to the power of 9. Yep. Then we have to subtract off 1, 2, 3, 4, 5, 6, 7, 8, 9. And we start with a 6. So how many options is that? 1. And it says I can't repeat, so I box and hold it, correct? Remember the whole boxing and holding? Then how many do I have left? 9 then. 8, 7, 6, 5, 4, 3, 2, which is actually 9 factorial. And what's the difference? What do we get? Can you just give me the numbers? We also forgot sentences the entire way through here. So, the 7 cars, 30 parked, 144 ways. This one says how many ways? 720 a car. And then this one. The 2 sin numbers. Okay, this says what? What do you think you should do? Your turn. So there's 3, I think. 1, 2, 3. Work on those 3.